AI creates new elements in virtual labs, Chemistry Reborn. For centuries, the periodic table has been the chemist's sacred text, a grand, orderly map of the building blocks of reality. From Mendeleev's prophetic dreams to the painstaking, atom-smashing work of modern labs, each new element added to its ranks was a monument to human ingenuity. But this process is slow, expensive, and fraught with peril. The elements at the far end are so unstable they vanish in a flash of radiation, often before we can even say we knew them. Chemistry, it seemed, was reaching the outer walls of its known universe. But then, a new alchemist arrived, one that doesn't wear a lab coat or handle toxic materials, but thinks in silicon and calculates at the speed of light. Artificial intelligence. Welcome to the virtual lab, where chemistry is being reborn not in a fume hood, but in a server rack. The old way of discovery was a physical, brute force affair. Imagine teams of scientists bombarding a thin sheet of one element with the nuclei of another inside a particle accelerator the size of a subway tunnel. After months or years, they might detect a handful of atoms of a new element, which then decayed in milliseconds. It's like trying to study a snowflake by throwing two glaciers together at relativistic speeds and hoping you can spot a unique, new flake in the resulting avalanche before it melts. It's heroic, but it's also comically inefficient. The cost is astronomical. The materials are often dangerously radioactive, and the entire endeavor is a bit like playing cosmic dice with profoundly bad odds. Enter the AI. Its approach is so fundamentally different, it almost feels like cheating. Instead of smashing atoms together in the real world, AI creates a perfect digital simulation of atomic physics. It uses the known laws of quantum mechanics, the bizarre and counterintuitive rules that govern the subatomic world, as the rulebook for a universe-scale video game. Then it does what AIs do best. It plays the game, and it plays to win. With brute force computational power and sophisticated machine learning algorithms, an AI can combine and recombine protons, neutrons, and electrons in countless trillions of configurations, all inside the pristine, risk-free environment of a supercomputer. It's the difference between trying to build a working airplane by randomly welding scrap metal together versus designing and stress testing it in a flawless flight simulator. The magic and the comedy lies in the AI's utter lack of human preconception. A human chemist brings intuition, but also bias. We are drawn to patterns that are symmetrical, beautiful, or analogous to what we already know. An AI has no such aesthetic hang-ups. It is a literal-minded, goal-oriented genius. If you task it with finding a material that is supremely hard, it might suggest a crystal structure that looks like a bird's nest built by a drunk squirrel, a form no human would ever have conceived, but one that, according to quantum law, is unbelievably robust. It is the ultimate outside-the-box thinker because, for the AI, there's no box. This has led to some astonishing, almost whimsical discoveries. We are not just talking about new elements in the classic sense, though AI predicts the potential existence and properties of super-heavy elements we haven't yet physically created, but entirely new forms of matter. Take the recent case of virtual perovskites. These are materials with a specific crystal structure that are excellent for next-generation solar cells. Researchers tasked an AI with designing a more efficient and stable perovskite. In a matter of hours, the AI returned a short list of promising candidates that had eluded human scientists for a decade. When the top candidate was synthesized in a physical lab, it worked spectacularly. The AI had effectively conducted 10 years of research and development over a long weekend, without ever getting its hands dirty. The process is a hilarious and humbling role reversal. The human scientists are no longer the master chefs, carefully measuring ingredients. They have become the restaurant owners who simply state, "I want a dish that is delicious, nutritious, and cheap." The AI, then, is the chaotic chef who proceeds to invent a recipe using combinations of seaweed, mushrooms, and a specific type of volcanic rock that somehow results in the most amazing meal you've ever tasted. You don't know how or why it works, but the result is undeniable. This is the black box problem of AI. Sometimes we get the answer without fully understanding the path the AI took to get there, forcing us to trust the digital oracle. The implications are staggering, heralding a new golden age for material science. The dream of a room-temperature superconductor, a material that transmits electricity with zero loss, has been a holy grail of physics for over a century. An AI, churning through hypothetical atomic arrangements, could pinpoint a candidate material, revolutionizing everything from power grids to quantum computing. We could discover alloys infinitely better for aerospace, polymers that revolutionize medicine, and catalysts that scrub CO2 from our atmosphere with unparalleled efficiency. The bottleneck shifts from discovery to synthesis. The AI tells us what is possible, and our job is to figure out how to build it in the real world. Of course, this brave new world is not without its perils. The same technology that can dream up a miracle drug could also conceive of a hyper-efficient explosive or a novel chemical weapon. The speed of discovery threatens to outpace our capacity for ethical reflection and safety testing. The virtual lab may be safe for us, but what it designs can have very real-world consequences. Furthermore, as we grow reliant on these AI oracles, we risk a slow erosion of our own fundamental understanding of chemistry. Why bother learning the intricate dance of valence electrons when the AI can just give you the answer? Yet, the potential for good is simply too vast to ignore. AI-driven discovery is not the end of human chemistry. It is its glorious augmentation. It frees the human mind from the drudgery of endless, blind experimentation and elevates our role to that of grand question askers, visionary explorers, and wise interpreters. We set the destination, and the AI charts a million possible courses through the infinite seas of chemical space. Chemistry is being reborn. The clinking of beakers and the hiss of Bunsen burners are now joined by the silent, whirring hum of processors. The periodic table, once a completed map, is now recognized for what it always was, merely the first page of a story that is still being written. With AI as our co-author, we are turning the page, embarking on the greatest voyage of discovery since the original scientific revolution. The elements of tomorrow won't just be found, they will be dreamed into being. If you found this video informative, please like and subscribe. It will really help this channel out. Thank you for watching. Stay tuned for more informative videos coming.